welcome our presenters today, Josh Dolitsky, who is the founder of ChartMuseum and also a software engineer here at Codefresh, as well as Stef Arnold, the senior software engineer at SUSE, working on Kubernetes and the CaaS platform over there. So with that being said, just a few housekeeping items. We do have the Q&A button, so as we go through, feel free to ask questions and make comments in there, and we will try to address those either during the presentation or afterwards during a Q&A session. This is being broadcast on Facebook as well, so feel free to send that link to any of your colleagues that'd like to join. We appreciate feedback. We appreciate social media engagement. Those things help us know that this kind of broadcast is worthwhile and that we should keep doing it. So with that being said, and introducing our presenters, I will let Josh and Stephanie take it from there, and we can jump right into the outline.
All right. All right. Thanks, Dan and Josh, for having me here. I guess I'll kick this off. Welcome again, and I'm excited to be here. So today we're going to talk about Helm and ChartMuseum. We're going to talk about Helm first, just because it's kind of the basis on where ChartMuseum came from. Won't spend too much time on that though. Then we'll talk about ChartMuseum itself and how it works and why it solves, well, how and why it solves all the problems that we have with sharing these charts between each other. And then we're going to jump into the good stuff, Codefresh and how we're going to do CI/CD, working with a live cluster. And so let's just jump into Helm. All right, so what is Helm? It is essentially a package manager for Kubernetes. Just like NPM, Yum, all of these things, they manage kind of two parts of the system. They have the packages themselves, as well as their dependencies. So it manages what is available to you on your system. And then it also manages the install part. So it can handle making sure that your system actually has the dependencies, and as well as removing packages. Helm does the same thing with the added templating function. So with Kubernetes, manifests are the files that are used to describe a deployment on top of Kubernetes. Helm takes those manifests and turns them into more of a templatized version to allow for more flexible and, in a sense, easier to read deployments, especially in terms of dependencies. And these are referred to as charts. And okay, so back to what we use Helm for, just its packages and installation. And Helm itself is a little bit different than some because there are two parts to it. Because Helm is designed to be used externally to your cluster as well as within if you choose. So there are actually two parts. There's a client and a server. And the server component is called tiller. So here I just have a couple of commands that you can use client-side only in the event that you are authoring charts, but you're not necessarily deploying to, say, a production cluster, like maybe you have Minikube or something, but you can run things like fetching packages, searching, linting, and of course creating the package without having a cluster. And then the various operations type commands, as I like to call them, installation and listing, like what's currently installed in your cluster. These are the ones that make use of tiller. So that's kind of Helm in a nutshell. So the thing is now we're left kind of in the middle, the packages. Where do they come from? We're grabbing them from somewhere, we're packaging them, and they need to go somewhere. And then even how Helm manages repositories, because they can come from anywhere. They can come from any web endpoint, and Helm can manage many. And the way that it does that is an internally managed YAML file, which basically points to each endpoint, each ref, if you will, and it will tell you what versions of which package are available. So how do we handle these packages? Maybe Josh can tell us a little bit about that.
I can. Were you gonna jump into command line, or
Oh, that's right.
are
I
we
was going to
skipping?
show a little bit of the command line, wasn't I?
Dan, are we able to switch share?
I think
Yeah, just go ahead and hit share screen.
that's right. I think I can.
Who's up on sharing?
Steph's gonna show some Helm stuff.
Okay.
That's right. Okay, so I am here in my terminal, and I have my kubeconfig and my Helm set up to speak to my cluster running in AWS currently. Just going through, so as usual, Helm Help is the first place to go. Have all of your commands and some handy references here. So let's see. I want to go back to Helm list. Helm ls is the same thing. We have an alias. So this is kind of the beginning. We say what is currently installed and what is being managed by Helm. Because Helm, if you install something with a kubectl applied, for example, it wouldn't show up in this list. But for here, we can kind of audit what we've been doing with our cluster using this Helm. And we can also drill down and start looking at like more details. Like maybe we want to know things that have been deleted only, or maybe only failures. Let's try it. Awesome. Nothing failed. Oh, but we deleted a few though. Okay. So that's kind of just the overview portion for operations stuff. Let's see, what else can I show you that's cool? Earlier, I mentioned that Helm templates or charts are really just manifests that have been turned into templates. Helm actually has a neat way of showing you the actual manifest that would be applied. There are two commands, this dry run, which of course, if you gave it a chart and said to install with dry run, it simply says, I have a release name, but then it does nothing. And debug, when it install, will simply show you more logging. But these combined, when given either a chart remotely or a local one, as I'm choosing to use, you can see that I have the full, like basic copy paste manifest.
Yeah, maybe show a little bit the just really quick what the template looks like and how things are passed in and how you can kind of do maybe like a set argument to override.
Yeah, for sure. So the very basics of a chart is what you see here. We have a chart YAML, README, of course, always, and a values file. That's essentially just keys and values. Then we have our folder templates, and this is where we describe just everything that our application requires. The deployment itself, persistent volumes when applicable, secrets. And so let's just take a quick look. I'll just open chart first. Pretty simple. Really, there is the version that we are talking with here, Helm, the application version, the chart version, and very basic metadata.
Yeah, so it's important to note the difference between the application version and the chart version, because you may have the case where your chart is in a state where it creates your Kubernetes resources the way you want it and you never change that. So you version that once, but you may increment the Docker image that it's actually pulling in, right? So you would actually just only increment the the Docker version and the app version on the chart.
Exactly. And we will show you the difference.
Yes, these things can be versioned independently.
Right. So I had the values file open. Again, very simple. There are no like variables or anything in here. It's just what you want per variable. And if we take a look at a quick template, let's look at deployment. So this is it in a nutshell. We have a couple of different ways to drop in our values. We can grab them directly. We can also actually include entire references through the inheritance, as well as just simply dropping in an entire section in indenting. Just because we decided the values file, doesn't need to be switched on. It's good as is. So yeah, that's Helm chart simply. Did I miss anything else that we should cover, Josh?
No, somebody was asking in the Q&A, any comments on Helm not allowing to specify version when packaging? So maybe show the Helm package command.
Yeah, actually.
So actually creating a chart package that is what actually, when you do the Helm install, it downloads the chart package to install. But to the comment, Michael, there is a way to specify a new version than that's in the chart YAML file, and I think it's just by passing a -- version. And I'll show you in a bit. We actually have a Helm push command that allows you to do that too. But go ahead, Steph.
Oh no, I just while you were explaining, I just really quickly bumped my version and ran the Helm package just to show the output. It's very simple. It just drops it to where you ran the command from, basically. I'm not sure if that addressed the question from the Q&A, or if you were talking specifically about
I think what he's asking is there a way to keep the version out of chart YAML almost? So I think you can do Helm package -- version equals 1.3.4 actually.
something like this.
I think so. Yeah. So there's a way around that if you wish to manage that version in your CI or something like that.
Yeah, that's true. That's a good point. And I guess the same with a Helm fetch. We'll also grab, let's see, what's a good version? Is there a 130? There is. So it works similar. All right. And with that, do we want to jump into ChartMuseum? Are there any other questions about Helm before we move on?
Let's see. Looks like there's a few more questions. I don't know, Dan. Do we answer the questions now or?
Yeah, what I would encourage you to do, actually, since there are a couple of questions, would be let's move forward and then let's come back and address the questions at the end, because it'll be easy to lose the thread of the whole thing that you're doing. So let's move forward and we'll come back to the questions.
Okay. All right. Dan, do you want to go back to presentation, or I can share?
Yeah, I stopped mine if
Sure, I got it.
Yeah, so really quick, somebody's asking also in the QA right now, it's the difference between the publishing your own charts and the community charts. And the only difference is that these are coming from different chart repositories. So I don't know if Steph showed, but there's a way to list all your repositories that you have. And out of the box, Helm comes with this stable one that contains popular applications like WordPress, etc., that you can install off the just like off the shelf. But if you want to author your own charts and publish your own charts for other people to use, you need to host your own repository. So a lot of people do this with simple object storage such as S3. But if you're working in an environment where you're trying to host one repository and have multiple different teams publishing their applications to the same repository, managing that becomes an issue because there's a file that tells the client what are all the packages available here, and that needs to be managed manually. So really the original problem that the ChartMuseum project solves is to fix that issue. Dan, can you, yeah. So this is kind of what I was talking about, is if you're, let's say, just using an S3 bucket, you may have two people, two different CI pipelines or what have you, and you're doing a Helm package like Stef showed, and then you do an AWS copy command to put it into your bucket. And above the red line, you can see that's all fine. If everyone's handling their own app, there's no issues here. Below the red line, you can see a possible condition, possible race condition where people are trying to manage this index file on their own. And there's some more interesting approaches here that I encourage you to take a look at. I saw something a while ago where the management of that index file was done in the Lambda function. So it's pretty neat. But simple solution is to run a ChartMuseum instance, and ChartMuseum basically manages that index file for you, and every time a request comes to the server, it gives you the up-to-date versions that are in your S3 bucket or wherever you're storing your charts. This is this is just a nice new logo that we have. So, and the project's written in Go, so it actually includes the Helm library itself to manage charts and to manage the index, and so you can expect that things look the same way that the Helm client is expecting things to look, because we're using the Helm library itself. And so basically back from the other diagram, this is getting rid of everything under that red line, right? So if people are just publishing their charts to a bucket, you put a web server in front of it, ChartMuseum, and when the Helm CLI is asking to install packages, it goes here, that proxies that request and grabs the correct chart from your S3 bucket. And this is an open source project, so we've gotten a lot of love from people in Kubernetes world. Lot of big companies that I don't know that I'm at liberty to share are using this behind the scenes to great success, and we've had a lot of positive feedback and a lot of great contributions from people all over the place. So you can go to github.com Kubernetes-Helm/ChartMuseum, and the Kubernetes-Helm organization is actually it's similar to the Kubernetes incubator, but it is the Helm incubator. So it also hosts the project Monocular, which came a while ago, which you can check out as well, which is actually an open source UI for a Helm repository. And I think we'll share these slides too, so this link will be in there, but you should be able to just Google that. So yeah, really briefly, ChartMuseum was intended to follow the documentation that Helm created for chart repositories. And really the only requirements that that says is that it must be an HTTP accessible server that houses this special index YAML file. And then it also serves chart packages. I won't get into provenance files because they're not very popularly used, but you can also store provenance files here, which are Helm's way of signing packages and enforcing integrity. You can run Helm install with the -- verify flag that will fetch this file as well and verify it. But that's pretty much it. It manages that index and makes sure that what the clients are asking for is what they're getting. On top of that, it also has a common interface for storage. So we've had a lot of pull requests come in to add new storage types. So it started off with just Amazon and Google, and since then, we've gotten Azure and Alibaba and also OpenStack as of last week. So, so really, like, even if you're coming from within your company, you're using an S3 bucket, and you're running into this issue with race conditions, or that's not working for you. If you have your charts sitting in object storage, all you have to do is configure ChartMuseum to point to that bucket, and it should just work the same as it was before. So in addition to working like a repository, there's also extra routes here that you can use to upload your package. So instead of doing that AWS CP command, you can actually just do a REST call to ChartMuseum API, and that will take the chart, verify it's a real Helm chart, and then put it into your bucket where you're storing it. You can also delete charts with a delete endpoint, and then there's also a few endpoints for retrieving your chart index as JSON. So I don't know, if you're building some web UI and you want to be able to query what's in your repo, you could use those endpoints. All right, so my turn to run the gauntlet here. So I'm gonna show just a little bit of getting started with ChartMuseum. So ChartMuseum can be installed as a binary. Let me just actually pull up the GitHub page really quick. So very simple, similar to a kubectl or Helm. You can curl it down, change permissions, and move it to user local bin. More popularly, probably, is the ability to use it as a Docker image. So it is on Docker Hub under ChartMuseum, which was the original location of the project. And this is basically what's used in the Helm chart as well. So you should be able to also do, we don't give you a good command here, but you can do Helm install stable ChartMuseum as well. And this is pointing to that Docker image. But anyway, I'm just going to use the binary and keep it local for now, just to kind of give you guys the details. So let's see, let's say I have an S3 bucket here, and I have two chart packages, a Kafka and a Zookeeper package. And I can run this command here, and I can say, this is my bucket, Helm Summit. I'm sorry, I'm reusing the one from Helm Summit. By the way, I actually met Stef at the Helm Summit because we both gave talks on Helm and ChartMuseum. So you can check those out. Those are on YouTube as well. But anyway, yeah, so you basically say what port you want to run on, what's your storage provider, and then the last three options are specific to the storage provider that you give it. So I will run this right now. And before the server starts up, it will actually, you can see that it's trying to regenerate this index YAML, and it goes and downloads the packages from S3 and creates the index YAML file. So if I do a simple curl to index YAML, you can see this is the format of that file. It basically has an entries block or an entries object that has the keys as the chart name, and then the chart, that's basically an array of objects that contain metadata about each specific version. And you don't need to mess with this file yourself, because the Helm CLI knows to look for that when you're adding it as a repo. So I can do something like, this is the command for adding a new repository. And so you give it the name that you want to refer to it locally. So you saw earlier how we're doing Helm install stable XYZ. That's just a pointer to that URL. So I do this now. Webinar S3 has been added to your repositories, and you can see the requests coming in on the ChartMuseum side of things. And now if I do a Helm search, you can see that Kafka and Zookeeper chart there that were in the bucket are now available for me to install. So I can do things like Stef was showing and fetch the chart. You can see the Zookeepers right there. And I was saying that there's actually a ChartMuseum API for uploads. And there's also, so that can be done with a simple curl like this. But we also have a Helm plugin. And what the plugin does is it adds a push command to your Helm client. So if I do Helm plugin list, you can see that that's installed. So if I want to now upload a chart to my bucket, I can just do Helm push, the name of my package, You can also point it to a directory, and you can skip the Helm package step. And then the name of your Helm repo. So you can see the request coming in for the upload, adding file to storage. And then if we go to S3 here, there's the chart here. And now if I do Helm repo update, which means Helm repo update means give me the new index YAML. And then I do that search command again. You can see that your custom chart is now in your internal repository. So really, this is a tool for hosting your own chart repository, sharing charts with other people, either inside or outside your company walls. And it's also kind of a tool for to allow you to do your Kubernetes application CI in such a way that you can rely on what the repo is telling you. Let's see, I think, Steph, is there anything else I'm missing here that I should show?
No, I think you covered all of the manual steps that ChartMuseum does for you.
Okay.
Move into move into Codefresh.
Sure, let's do it. I'm going to stop my share. I think we have a few more slides.
Yeah, I think we have a couple more slides. Right. Okay. So, right. So thanks, Josh. At that point, we now have a running chart server, so we can actually host packages that we wrote, not just retrieve community charts. Right, authored packaging and uploads. So how do we get this deployed based on these little pieces that we have figured out? If you go to the next slide. This is kind of what we are thinking, ideally, for a pipeline. And back to the question that was a little earlier about the two different versions, a chart versus app, this is where we're going to handle that. Because it could be that we just decided to change our underlying application, the web page text, for example, but the chart itself works just fine. So we would like to design a pipeline that can handle that change without having to release a duplicated artifact that just has a version bumped. So with that, we will see what that looks like in Codefresh. Next slide. We will see what it looks like in Codefresh. And first, so now we're at the point where we want to actually deploy it somewhere. We need our cluster. And we're just going to take a quick second just to talk about how I did that to set up the SUSE cluster on AWS for this demo. And then we'll jump into Codefresh. So if you go to the next slide, in the interest of time, I just had a couple of screenshots just showing what this looks like. So you spin up what we call an administration node, and you are presented with an application that is already running for you. So it's our bootstrap process, so to speak. And it will also allow you to create a username before you get to this page. So then you can just log in. And if you can go to the next slide, please. So we're brought to this page. First thing, we just want to establish who our administrative node is, and it's ourself. And this is an auto-populated field that is generally correctly slurped in. We also have an option to install Tiller. That's the that Helm server-side component just to try to get you up to speed faster, and because this is a SUSE certified tiller instance. And then we have a couple of other network settings. I mean, the network is completely defined for you, but you can change those settings. You can add also registry mirror for offline installs. Next slide, please. And then the cloud image provides you with this handy screen that will allow you to generate the rest of your cluster. You can specify a particular type of instance, one that's here as a suggestion for your workloads, or you can specify the exact type of instance. And then you tell it what cluster size you'd like with the slider. And it got maybe cut off at the bottom, but there's just some networking, again, automatically pulled in from AWS, because part of it is generated automatically as well. And is that the last slide? Okay.
Yep. So now I think it's time to jump into that live demo and show how this stuff all comes together.
Yeah, I think so. Josh, would you like to kick off?
I sure can, sure. So let me get back here.
Actually, let me snag it because I was going to show screen to
adding the SUSE cluster.
Right.
And I can hop on after if you want.
Great. There, perfect. Okay. So I'm not sure if you can see that pop out, but no, I'm going to move over here. Okay, so I'm here in my Codefresh view. My repository is already here. So if we go down to the Kubernetes tab, we have a couple of different views. This is where my cluster is loaded currently. And actually, yes, I believe you add the cluster in this view. And for something like SUSE, you would pick the custom integration. And then it's just the certificate and your token and the name of your context. You just plug those three values in to this page and you're good to go. And you can further manage your integration from your account settings if you want to change anything after adding or removal. So that's what I wanted to cover before we went into Codefresh.
Maybe show really quick too, we have the Kubernetes tab on the left that actually will link to your cluster and show you kind of what's running there.
Oh, yeah, the dropdown. Yeah. So I didn't show this before.
That's pretty much it.
Okay. I just need to drop down. So
I can take over if you want.
Yes.
So while you're gathering that, maybe just to reiterate all the moving parts and components of this demo, basically you're going to make a code change. It's going to build a Docker image. This is going to update the Helm chart. It's going to deploy to the Kubernetes cluster that you put together using the SUSE CaaS. And then ChartMuseum is going to store the release version of the Helm chart that you created in that process. Do I have that all kind of mapped out correctly?
Yeah, I think I'm going to show that diagram one more time before we hop in here. Sorry, I didn't have an easier way to get this out of the thing. But yeah, basically we're going to try to, in one pipeline, manage both the Docker image and the Helm chart. And to do that, in Codefresh, you can set up a pipeline. You can have multiple pipelines per repository. You can set up environment variables and encrypt some of them. So this URL, actually, we didn't get into that, and maybe we don't have so much time, but you could see in the SUSE cluster, we actually have a ChartMuseum running there. Actually, if you go to Helm releases, that's probably better. You can see the CM webinar Helm release running in this cluster, which we've called local, which is the cluster that Stef added earlier. And it's running the ChartMuseum chart. And there's all sorts of cool things you can come in here and see in the releases page, like upgrade information, and it will even show you actually the diff of what's changed here. But anyway, back to the pipeline. So all Codefresh pipelines can be defined as YAML. And so we have a repo here under Stef's name, hello CF. And we'll also share this after the presentation, or Dan, I don't know what the best way to get this out there is.
So there's just a note, the replay will be posted along with a blog post, all the relevant links. And then on the last side, we have links to all of these things that you guys are working with. Okay,
cool. So really quick, this repo, which is, I think, something generously copied from somewhere Nginx land, we have running here, and all it does is it's an Nginx configuration, and it returns 200 and says hola, and that's running. So back to the Codefresh YAML, the way that we're doing this is we have some trickery up here. Maybe I need to zoom a little bit, one sec. So we have some simple shell scripting here that could probably be put into a script itself, but what we're doing is seeing if certain files changed in the last revision. So like in this diagram, this is, did the version change for Docker? Then we're going to push a Docker. Did the version change for the chart? We're going to push a new chart. And that's actually going to push to the CM webinar ChartMuseum instance that we have running there. From there, we run unit tests, which actually we don't here. We don't run the unit tests. But this is where you could do some unit tests on your code. We have a build step, which Codefresh has a built-in type build, which means if there's a Docker file sitting there, it will just build it and push it to the Codefresh internal registry. We have a push step, which Stef has added her Docker Hub, credentials so that she can push images to the Stef SUSE hello CF image, which I believe is public, right?
Yes, this is the public Docker Hub, not any built-in resource.
Right. So that's somewhere there on the internet. You can find it. We're going to push the latest tag as well.
Docker Hub Stef SUSE.
Yes.
And by the way, I'm a developer and I have a change to my web page. Would you like me to commit it so we can see this deployed?
Yes, I was just going to get into that. So let's see what happens if Stef pushes a change. Actually, really quick, I wanted to just finish so the last few things are testing the chart, which right now we're just running Helm lints, which makes sure all the files are formatted right. Packaging the chart, and then adding the repo like we were showing in the demo earlier. And this is pointed to the ChartMuseum instance running on the cluster, running that Helm push command, which is baked into the Codefresh CF step Helm image. And then we decide whether we want to trigger a deploy based on have we pushed the Docker or the Helm chart. If not, if we're just doing like a README change, we don't necessarily want to trigger a redeploy and staging. So there's actually a Codefresh CLI to run other pipelines, and we have this deploy staging pipeline, which points to a different YAML file, which you can take a look at. But it's some Codefresh magic to install your chart on your cluster. But anyway, Steph, yeah, do you want to push a change and we can see this go through?
Yes. I have updated our web application.
All right, so let's see what she changed here. She changed that hola text to hello from Codefresh, and bumped that version, which is going to tell us to push the Docker image. And if you look at the build, you can see we're building that image. Here was that those crazy shell scripts at top saying push Docker true, push Helm false, because we did not update that chart YAML version. So now this is being pushed to Docker Hub with the new tab 1016. Linting the chart. And you can see the push chart is skipped because we have not changed the chart YAML. However, we are going to trigger the deploy because we pushed the Docker image. And so now you can see this new, the pipeline name is here. You can see this deploy staging is firing off. And what that does is just runs a Helm upgrade with the new version of the Docker image passed in. Set image, you can see the set image tag 1016, which is the new version. And that should be deployed. And there you go. You have your application updated, coming directly from your Git commit. So I think that's pretty much the demo. There was a few. We actually Codefresh just launched yesterday oh sorry, that's the wrong. We just launched managed ChartMuseum repositories. So we didn't unfortunately have time. Oh, Steph, you would have to show it. But basically, every account when you log in, when you sign up, you get this CF Helm Codefresh repository, which you can just, without installing ChartMuseum, push charts directly to. So check that out. But I think that's pretty much all we have for the demo, and I hope we have some time for the Q&A.
Awesome, thank you. Okay, so I think actually a lot of the questions that I saw were likely answered during that demo portion, but thanks for putting that together. I think it makes a lot of sense, and when you see the whole flow come together, it makes it easier to understand all the components. So with that, I want to move over to the questions portion of this, and I think we answered some of these. There was a question about how does ChartMuseum API handle posting chart that has multiple subcharts? So this is kind of a question about charts of charts.
Yeah, so I believe, Steph, correct me if I'm wrong, before you run Helm package, you're supposed to run Helm dep up, which will look at a file called requirements YAML and requirements.lock. And that will get, that will download the tarballs into a directory, special directory called charts. And then when you Helm package your chart that has the dependencies, it will bundle those tarballs into the tarball. So it's a tarball of tarballs. So it's not something to do with ChartMuseum API. It's to do with the way that Helm manages dependencies.
Okay. And then there is another question. Which are the mandatory Kubernetes resources, deployments, pods that should be installed as prerequisites for this pipeline?
Prerequisites to, I'm assuming, the Codefresh pipeline?
Probably the one we just showed, I'm guessing.
Yeah.
I think that's the question, and I don't think there are any prerequisites. It's basically, Stef, I think you set up the cluster using SUSE CaaS, and then you just connected it to Codefresh, and then you were done. I mean, I don't think that there was an extra step. There was Helm. Helm was installed on the cluster.
Yeah, there was a checkbox that was in that on that create page, right? Stuff that's like install tiller, which is the server-side piece.
Correct, and that makes sure that the service role has the correct permissions, like listing namespaces.
Yeah, okay, good. Then there was a question about how this compares to Cloud Foundry. I'm actually not super familiar with Cloud Foundry. This is the AWS. I think that's more of a question for you, Stef.
I mean, it's a fair question for sure. Although unfortunately, I am very familiar with AWS and less so with Cloud Foundry. So.
Yeah. Okay. What are the prerequisites for Monocular to work with ChartMuseum?
So I think I was actually trying to get this working a while ago, and so I think you basically first run a ChartMuseum, and then there is something in the Monocular configuration that you can list multiple repositories. So there's actually a Monocular, I'm not sure if it is the web interface, but there's a site called hub.cubeapps.com that Bitnami, the company Bitnami, manages. And they're running against the stable and the incubator repositories. But I think you can run this locally and point to any number. You can point to the stable, you can point to your own all-in-one UI. So yeah, definitely a question for the Monocular folks, but it is possible. It should be possible.
Cool. Good answer. And then I think we only have time for maybe two more questions here. This is a question for you, Stef. How does the SUSE kind of Kubernetes CaaS differentiate from a lot of the other Kubernetes offerings that are out there?
I'd be happy to talk about that. So I kind of alluded to before to offline installs, because one thing that the SUSE CaaS offering is good at bare metal. So a lot of solutions out there are either single node, like testing clusters, so to speak, as well as they are kind of very deeply integrated with the cloud provider, and usually it is Google. But SUSE does not have that. It takes more of a general approach, and it also allows you to set up a hybrid cluster, so that can be a mixture of bare metal and virtual. Because I'm not sure if you jumped in late, but a little earlier in the slides I showed a view where the Bootstrap script would allow you to choose the instances that you'd like to provision your cluster with.
Cool, thank you. And then there's also a question about managing conflicts between Helm and kubectl packages that maybe either of you would have more insight into that.
I was wondering if that referred to versions, like the Helm versus Tiller versioning, or is it specifically Kubernetes versioning?
It didn't specify, basically just said, how do you deal with conflicts between handling Helm and kubectl packages? So I think the question is sort of, let's say you're doing some manual deployments with Kubernetes and you're also doing Helm, how do you keep them from sort of running over each other?
Right. Okay. Yeah. Actually, I believe that Helm itself will not edit any resources that it does not have.
That it doesn't own, right?
Manifest, I believe. Yeah. So I suppose if you'd made a manual change to a resource, that Helm would end up deleting later, but somehow was hooked into another process. You could get yourself into some trouble. But as far as separate, like completely separate applications that are deployed differently, nothing is coming to mind that would interfere necessarily.
I'm kind of reading the question too as how do you, like, which Kubernetes versions work with Helm versions? And yeah. I think that actually is a tricky problem.
That's true.
But the release notes, like if you look at certain, you may be locked down to a lower version of Helm based on which version of Kubernetes your cluster is. So
that's correct. Yeah. Yeah, I usually refer to the release notes, or I also know which version had worked for me. So I just missed a little bit of learning curve there.
Yeah. Okay. Last question was, how do you handle caching app dependencies such as NPM packages instead of bundling them with each new Docker image? I don't think that you don't bundle them with each new Docker image. As far as the caching goes, I think you probably approach it from the build standpoint of how do I just basically make my images efficient when they build using those dependencies, which in this instance, when you're building with Codefresh, it actually is going to cache all of the Docker layers. It's going to cache your build volume and all those things so that you're not re-pulling them every time you build. They only get pulled when they change. So that would be my answer to that. Did you have anything to add to that, Josh or Steph?
I'm not a fan of this approach, but you could always check in your dependencies. I've seen some projects like Go projects that check in the vendor directory, and that's kind of, I think there's nothing super wrong with that other than you just have so many files in your repo.
Yeah.
But it does give you confidence that you have the right versions because you're manually updating those and pushing them in, and it will actually speed up your build quite a bit.
Great. Well, with that, I'm afraid that we are going to have to come to the end of the webinar. I do appreciate everybody joining us. Just a last housekeeping notes. We will publish this as a blog post on codefresh.io/blog. You can also sign up for a free Codefresh account there, and you'll automatically have a ChartMuseum sort of instance on your account that you can go and play with and start pushing and pulling charts to. So with that, I really appreciate it. I think that SUSE offers a free trial for using the Open CaaS, the Kubernetes CaaS platform, and Codefresh, of course, has a free tier that's 120 builds a month. So no reason not to get started. And on the Codefresh end, on our website, we also offer sort of one-on-one demos and setups. So happy to jump in and do one of those if you're interested. And with that, we will say goodbye and thank you. And feel free to check out our other webinars, codefresh.io/events. You'll see all the ones we have coming up. We're going to be announcing some things with Canary and Blue-Green deployments, demos, webinars around that, as well as potentially some work with Istio. So stay tuned for those things, and we'll see you soon. Thank you.
Bye, everybody.
Bye, everybody.
Bye.